Mazda Rotary Engine 16X. This is the next generation rotary engine that was exhibited at the 2007 Tokyo Motor Show. That engine has different dimensions than the 13B. The 16X engine used a direct fuel injection system that directly into the operating chamber, and it excited people as the rotary engine of the future. What is the reason why rotary engines have not become widespread? It is clear that the problem is poor fuel efficiency. The last video was the story of RX-8. Actually, I own RX-8. And again, I used to have the RX-7 FD3S. Maybe I'm not good at driving. There seems to be no big difference in fuel efficiency between the RX-8 and RX-7. For people who have never owned a rotary engine, I think they get the impression that the fuel efficiency of 6 km per liter to 8 km per liter is very poor. In defense of the RX-8, the best highway record was 12 km per liter. As expected, fuel efficiency has never been this good with an FD. Why do rotary engines have poor fuel efficiency? This is because there is a large surface area involved in combustion. This is a comparison diagram with a single cylinder, but just by visually comparing the purple area, you can see that the surface area is large. The larger the surface area, the more energy is taken away as heat. If the surface area of the combustion chamber is large, the amount of oil needed to maintain airtightness and lubricity will also increase. This further reduces emission performance and requires recombustion in the exhaust path. It is necessary to supply a large amount of fuel by calculating the amount of energy that becomes heat and the amount of oil that is increased. Then, I guess we need to reconsider this surface area problem again. I'm sure Mazda's rotary engineers thought that way. The index of heat loss taken away from the engine wall is expressed as the ratio of surface area to volume and is called the SV ratio. Since rotary engines have a large internal surface area, many problems occur and fuel consumption suffers. In order to reduce the surface area, the dimensions of the new rotary engine HC have been reconsidered. This is the rotor housing of the new rotary engine HC. And this is the 13B rotor housing up to RX-8. You can see that the rotor housing has become taller, but what you should pay attention to is the peritoroid curve. The swelling of this curve has been expanded. This swelling changes depending on the rotary engine's generating radius and eccentricity. In 8C, generating radius R is now 120 mm from 105 mm on 13B, and eccentricity E is now 70.5 mm from 15 mm. The ratio of generating radius and eccentricity is smaller in 8C. The smaller this number is, the greater the swirling, and the less suitable for high rotation. Also, the movement of the apex seal that affects the wall of the rotor housing will increase. As a result of taking into account the loss due to such mechanical resistance, the current dimensions were chosen with an aspect ratio of 3.9. The 8C prioritized fuel efficiency over the sporty and exciting high rev range, so the maximum RPM was kept at 4,500 RPM. Additionally, due to this structural change and the depth of the rotor recess, the compression ratio has been improved from 10.0 of the 13B Renesis to 11.9. The compression ratio is the quotient of the maximum and minimum working chamber volumes. By changing the dimension, the aspect ratio was reduced by 12%, and the summer efficiency was also improved by increasing the compression ratio. However, it did not seem possible to achieve other improvement targets, such as pumping loss, emission performance, and knocking, with this alone. RX-8 engine, Renesis, jet air fuel mixing system. It was devised to blow back fuel that does not enter the working chamber and remains in the port into that. Because the place of the fuel injection process and the place of combustion process was very far away, a lot of fuel had to be injected to reach it. On the other hand, Mazda's Skyactiv series other than RE are basically direct injection engines. Direct injection is a system that blows fuel directly into the combustion chamber to operate with as little fuel as possible. Is it not possible to have direct injection with a rotary engine? Although it had been devised for the hydrogen rotary engine and 60X, it had not been mass-produced. Almost all surfaces of a rotary engine are sliding surfaces, so it's always oiled. With direct injection, there was a possibility that the oil coated on the surface would be blown away by the fuel, making it impossible to maintain sailing performance. It is best to inject fuel at a time that does not blow away the applied oil. It wasn't that easy. We don't know when that time will be or if it will happen at all. This is because we basically cannot see inside a moving engine. Therefore, Mazda Rotary engineers used MBD. MBD stands for Model-Based Development. Model has various meanings. This model has been visualized using vast amount of data obtained from past developments. Using their extensive data of Skyactiv technology, they were able to visualization and calculate the injection position and timing to avoid interference between gasoline and oil. In the certain B, there is a distance between the injector and the ignition position, and there is a lot of fuel from the intake port to the vicinity of the plug, which can cause knocking. In addition, since fuel that did not contribute to combustion was also input, such as an air pump and a summer reactor were installed to burn excess fuel on the exhaust side. In the 8C, fuel is injected at high pressure in several batches to facilitate mixing with air. Knocking is also prevented by latent heat of vaporization during fuel injection. With this method, it is possible to create a state where the gasoline is concentrated around the plug, allowing ignition to occur at the optimal mixture ratio and timing. With direct injection, the 8C was able to significantly reduce fuel consumption compared to the certain B, improve emissions performance, and eliminate the air pump. Dimension change and direct injection. The evolution of the 8C does not stop there. Mazda Skyactiv engine is an engine that continues to evolve to realize 7 ideals. This figure shows how these 7 factors are applied to a rotary engine. High compression, leaner fuel, faster combustion, improved combustion timing, reduced wall loss, reduced pumping loss, improved mechanical resistance. High compression is achieved by changing the dimensions and the depth of these rotor races. By creating an additional cavity in this races, the shape of combustion chamber optimizes the flame flow. I think about this image that skis the mixture of air and gasoline, lights the mixture while leaving a flow of gas, and spreads the flame evenly through by the round cavity. By eliminating the rear races and plug, only one combustion is required. Previous rotary engines had 2 plugs. It was a 2-stage combustion with a leading side and a trailing side. It used a lot of oil and gasoline for port injection method. Therefore, combustion could not be completed with a single large ignition, and subsequent spark plugs were also needed as an auxiliary. In addition, a large flame was generated on the leading side, which took many heat energy away from the inner walls in the engine. In the 8C, direct injection and the cavity slow down the initial combustion and align the flame expansion with the expansion of the combustion chamber, reducing heat transfer to the walls in the engine. Also, by using only one plug closer to the leading side and eliminating the recess on the trailing side of the rotor, optimize the efficiency of that once-off combustion, reducing the generation of unnecessary heat. By adopting direct injection and changing the rotor recess shape, combustion time and combustion timing have been greatly improved. I have explained several improvements so far, but in fact, the thing that has contributed the most to the evolution of the new rotary engine 8C may be the cooled AGR. Cooled AGR. AGR stands for exhaust gas recirculation. Exhaust gas equal inert gas and inert gas is a gas that does not easily react. Even when compressed or heated to high temperature, it does not react by burning. Cooled easy air is a system that cools the exhaust gas before using it. Cooled easy air is used for the following purposes: knock prevention, decrease in combustion temperature, lean combustion, slow the initial burning rate, suppression of heat loss from walls, reduction of pumping loss. In this way, cooled easy air can contribute to many things. Regarding knocking, in this case, it refers to combustion that occurs too quickly. If the exhaust gas remains hot, it may actually cause knocking. Therefore, the exhaust gas is cooled and returned to the intake side. The reason why knocking can be prevented is because the temperature of the mixture before combustion can be lowered. Rather, the temperature of the mixture before combustion is lower than when it is just air and gasoline. This is because the temperature will be less likely to rise if used together with easy air. This means that it takes longer to boil water and food than to boil water alone. For the same reason, it leads to a reduction in flame expansion at the initial stage of combustion, which lowers the temperature of combustion itself, which reduces the heat energy taken away by the wall surface. As shown in the figure, the cooled easy air inlet is located just after the throttle valve. It is ready for introduction even if the throttle valve is closed. For example, if you use a thin straw, you won't be able to drink unless you suck with strong force. If you use a thick straw, you can drink with ease, but you may end up drinking too much at one time. When you want to move your car slowly, you open the throttle less, but it's better to have less resistance to sucking in air. This resistance is pumping loss, and as long as the amount of air is controlled only by the accelerator throttle, this loss will always occur. Oxygen is required for gasoline to burn. What can we do to reduce pumping loss without changing the amount of oxygen at this time? That is, the throttle opening. Inert gas does not interfere with combustion. By installing easy air, it will be like having two straws, and you can reduce pumping losses while maintaining the necessary fuel and air. Up to the certain B, NOx generation was suppressed by enriched the fuel, and the hydrocarbons and carbon monoxide that were generated in large amounts were reburned in the exhaust path. NOx decreases at lower temperature. In the HC, NOx is reduced by lowering the combustion temperature using cooled easy air. It is now possible to operate with leaner fuel than before, and has evolved from a rate engine to a stoichiometric engine. In this way, many items have been improved by introducing cooled easy air. High compression, direct injection, improvement of combustion chamber with cavity, cooled easy air, changing dimension, variable hydraulic control. The HC is a new era rotary engine with significant improvements. There is no doubt that the 8th technical philosophy marks the beginning of a new history of Mazda Rotary Engine. We have overcome times like the current one before, so we can also overcome present day.